Number 8. Quantum tunneling. Classical physics operates on a strict set of energy rules. A ball can never roll over the peak of a hill if it lacks sufficient initial kinetic energy. This is the law of conservation of energy, a non-negotiable barrier. However, when scaling down to the level of a proton, reality begins to exhibit behaviors akin to a glitching source code. A proton, when faced with an electromagnetic barrier that it classically lacks the energy to overcome, suddenly appears on the other side. This phenomenon is known as quantum tunneling. It is not a rare anomaly. It is the core mechanism that keeps the universe operational. The sun burns through nuclear fusion, yet the temperature in the solar core is actually not high enough for protons to overcome electromagnetic repulsion and collide. According to standard logic, the sun should have flickered out long ago. But thanks to this barrier hopping effect, trillions of protons penetrate the energy wall every second to sustain the entire system's life. Even the semiconductor components in the device you are using operate by allowing electrons to tunnel through thin insulating layers, a state that traditional physics insists is impossible. The unsettling part lies in the mathematics. The Schrödinger equation accurately predicts the probability of this occurrence, but it requires the particle to pass through a region of negative kinetic energy. In physical reality, negative kinetic energy is a non-existent concept, an absolute absurdity. The particle does not break the barrier, nor does it go around it. It simply transits through a zone of physical impossibility to manifest at the destination. Viewed from a computer architecture perspective, this resembles a buffer overflow or data indeterminacy. When a system does not store position values as absolute coordinates, but instead maintains a probability cloud, it becomes possible for an asset to suddenly render at the wrong coordinates. The universe does not calculate a continuous trajectory for a particle moving through a barrier. It only resolves position probabilities. If the probability on the other side of the barrier is non-zero, the system will occasionally render the particle there. We are living in a reality where impossibility is merely an unresolved parameter, and matter can pass through the sturdiest walls simply because the computational engine allowed a minor margin of error in position resolution. Physics can precisely calculate these odds, but it is utterly powerless to explain the mechanism. How can a physical entity exist in a place where its energy is negated? The answer perhaps lies in the fact that the universe is not as material as we have always assumed. Number 7. The Boötes void. In 1981, astronomer Robert Kirshner and his colleagues mapped a region of space approximately 700 million light-years from Earth and discovered something that should not exist, or rather, a profound absence of things that absolutely should be there. It is a spherical region of space, roughly 330 million light-years across, containing almost nothing. Where standard cosmological models predict thousands of galaxies should be distributed throughout this volume, there is effectively a vacuum. This is a hole in the fabric of the universe. Cosmic structure is formed by gravity. Matter pulls toward matter. The result, after 13.8 billion years, is the cosmic web, a network of filaments and sheets of galaxies separated by voids. Typical voids reach sizes of perhaps 150 million light-years, but the Boötes void is more than twice that diameter. There is no known natural evolutionary mechanism that could produce such a massive displacement of matter within the time frame available since the Big Bang. Every computer simulation of cosmic structure formation, seeded with initial conditions, and run forward 13.8 billion years, produces results that match our observations everywhere in the cosmos, except for this spot. The probability of a Boötes-scale void appearing naturally is so low it borders on impossible. If the Milky Way were located at the center of the Boötes void, humanity would not have discovered the existence of other galaxies until the 1960s. From the inside, the universe would appear utterly empty and desolate. In open-world game programming, engineers use a memory optimization technique. only render the areas the player is currently approaching. Regions not yet visited are left as placeholder coordinates containing no detailed data. The system does not waste processing power on sectors where there is no active observation. A region of the map that is never triggered remains a blank, undefined void. The Boötes void has been studied for over 40 years. It remains there, defying every physical law regarding the distribution of matter. No natural mechanism has been confirmed to explain its existence. After 4 decades, it remains simply a part of the map that was never rendered. A glitched partition in the operating system of our reality. It is a dark, empty reminder that perhaps the universe does not bother calculating everything if no one is actually looking. Number 6. The double slit experiment. The double slit experiment is not merely a test of the nature of light. It is empirical evidence that reality operates according to a data optimization logic. In 1909, Jeffrey Taylor began a series of observations that completely collapsed the logic of classical physics. When single particles, such as electrons or photons, were fired through 2 narrow parallel slits, the result on the detector screen was not 2 aligned bands of impact, like tiny bullets. Instead, they formed an interference pattern, a characteristic belonging exclusively to waves. The anomaly arises when scientists fire particles one at a time. A single particle, theoretically, has nothing to interfere with. However, results show that the particle appears to pass through both slits simultaneously, interfering with itself and landing at a position based on a complex probability function. It exists in a state of superposition, occupying every possible path until the final point of impact is recorded. The true disturbance begins when a measuring device is placed at the slits to determine exactly which hole the particle passes through. At the precise moment observation becomes possible, the interference pattern vanishes. The electrons immediately abandon their wave nature and begin behaving like definite physical entities, creating 2 clean lines on the screen behind them. Remove the detector, and the wave behavior returns. Observation is the direct catalyst for wave function collapse, forcing the universe to lock in a specific value from a cloud of probabilities. In 2022, the scale of this phenomenon was expanded to molecules containing up to 2,000 atoms. These structures are large enough to be seen under a microscope, yet they still obey the rule, behaving as waves when unobserved and becoming particles when monitored. This confirms that the change in the physical state of matter does not depend on human knowledge, but rather on whether information regarding that state is available within the system. The parallel between this phenomenon and modern computer graphics techniques is impossible to ignore. In open-world games, engines use a mechanism called frustum culling or occlusion culling to save resources. The computer does not calculate the details of objects located outside the player's field of vision. These unobserved regions exist only as raw source code or unrendered data clouds. Only when the player's viewpoint is directed toward them is the data resolved and displayed as a definite image. The double slit experiment describes physics performing exactly this process. Particles do not possess definite states until observation demands a specific value. The universe appears to waste no computational power, maintaining the positions and trajectories of billions of unobserved particles. Instead, it maintains probability distributions and only resolves them when there is a request to retrieve data through a measurement. Modern physics can mathematically describe wave function collapse with absolute precision, but it is completely powerless to explain the core mechanism. Why does observation change reality? What is the exact definition of observation? Does it require human consciousness or simply an interaction between particles? No theory has been unified. We are standing at a rendering limit of reality, where particles only load data when necessary, leaving a massive question mark over the true nature of the spacetime we inhabit. Number 5. The dark flow. In 2008, Astrophysicist Alexander Kashlinsky and his team at NASA published a discovery that shook the very foundations of our understanding of universal laws. They tracked the motion of hundreds of galaxy clusters, massive structures containing thousands of individual galaxies, and noticed something impossible. A vast number of these clusters were moving in the same specific direction at speeds up to 1,000 kilometers per second. They weren't drifting randomly with the expansion of space or following large-scale structural distribution. They were being systematically pulled. This phenomenon is called dark flow, and it directly violates the cosmological principle. This principle asserts that on a sufficiently large scale, the universe must be isotropic, having no preferred direction, and matter must be distributed uniformly. Every calculation in modern astrophysics relies on this assumption. But dark flow tore it apart. The fact that hundreds of galaxy clusters are hurtling toward a single point implies a titanic gravitational force is tugging at them. However, within the entire observable universe, there is no structure with enough mass to produce this effect. Whatever is causing dark flow must reside beyond the borders of the observable universe, past the cosmic horizon, where light and information have never had enough time to reach Earth in 13.8 billion years. We cannot see it. We cannot measure it directly. We only see the assets of the universe being sucked toward a void. Consider this from a system architecture perspective. In a graphics engine, a game map always has a physical limit. Beyond that boundary lies unallocated memory, the fundamental architecture of the system itself. If the interface between rendered space and the undefined zone creates a data imbalance, objects near the boundary will accelerate toward the edge of the map. You don't see the cause. You only see the assets rushing toward the limit of the simulated world. Modern physics possesses the mathematical equations to describe this motion perfectly, yet it is completely helpless in explaining the mechanism. What lies on the other side? Is another universe colliding with ours? Or is the system simply processing data in a region where the observer is not permitted access? Later analyses remain contested, but Kashlinsky's team stands by the data. The directionality is real. Dark flow is not just a hypothesis. It is a rendering error in a system we once believed was perfect. It is a grim reminder that reality may just be a volume of space constrained by the clock speed and bus bandwidth of a much larger machine. The structure of the universe isn't just expanding, it is leaking beyond its own boundaries. Number 4. The speed of light. The figure 299,792,458 meters per second is commonly recognized as the speed of light. However, the true essence of the constant c does not reside in photon particles. Light travels at this velocity simply because it is massless, and this happens to be the absolute speed limit of reality. This is the maximum rate at which any information, causation, or signal can propagate through space. If the sun were to vanish this instant, Earth would continue to orbit an empty point for 8 minutes and 20 seconds because the gravitational information has not yet updated. You would witness the sun go dark before you felt the absence of its pull. Analyze this from the perspective of systems architecture. In any computational system, information propagates at a finite rate determined by clock speed and bus bandwidth. If cause and effect could propagate instantaneously across the entire system simultaneously, the processing load required to calculate all cascading interactions in real time would be infinite. The system would crash. The imposition of a maximum propagation speed prevents such a catastrophe. It ensures that distant parts of the system cannot affect one another instantly. Events are calculated locally, and information spreads outward at a capped rate, allowing the processor time to handle cascading consequences sequentially rather than simultaneously. The speed of light functions as a throttle, a hard cap on how fast causation can cascade through the system. What physics lacks an answer for is why this specific number exists. It is not derived from any other fundamental constant. It is not a consequence of geometry or thermodynamics. The universe possesses a maximum information propagation speed, yet no theory explains what set it. It is simply an input value, fixed and non-negotiable. Much like an environment variable in the source code of reality, this limit ensures that causal calculations do not exceed the processing capacity of the underlying framework operating the universe. Number 3. The Heisenberg uncertainty principle. In 1927, Werner Heisenberg established a strict limit on reality. You can never simultaneously know the exact position and the exact momentum of a particle. As you determine the position more meticulously, the information regarding velocity becomes increasingly chaotic, and vice versa. The product of these two uncertainties is always greater than or equal to a fundamental constant. For decades, the scientific community interpreted this as a measurement problem, the idea that the act of observation disturbs the object. However, modern experiments on entangled particles and tests of Bell's inequality have completely overturned that understanding. Uncertainty does not reside in human measuring instruments. It resides in the very fabric of the universe. A particle truly does not possess definite values for both properties at the same time. This fuzziness is ontological, woven into the structure of existence. Viewed from a system architecture perspective, this is a classic data optimization mechanism. In an open-world simulation, retrieving and storing every variable for every speck of dust across billions of light years would require infinite memory capacity. The most practical solution is data compression. The system only sharpens the variables within the direct focal point of observation. Anything not being queried exists as a blurred probability band, consuming far less computational resource than an absolute precise value. The Heisenberg principle is that compression algorithm. The universe does not store simultaneous values for conjugate variables. It maintains raw data bands and only resolves them upon request. When you attempt to scrutinize a particle beyond the uncertainty limit, you encounter pixelated noise, not because your tools are crude, but because data at that level of detail simply does not exist in the source code. Modern physics possesses the precise mathematics to describe this compression, yet it lacks any explanation for the execution mechanism. Why does this data compression apply exactly at this scale? What is enforcing the deletion of information when we are not looking? The math describes the phenomenon perfectly, but the core reason is entirely absent. We are observing artifacts, the fingerprints of an operating system, seeking to save processing bandwidth in the presence of a conscious observer. Number 2. The Mandela effect. This is not merely a psychological phenomenon of collective memory distortion. It is a fracture in the consistency of historical data that modern physics has yet to explain. Millions of unconnected people, separated by geography and culture, possess detailed, vivid memories of events that never occurred according to the official record. The iconic character of the game, Monopoly, Rich Uncle Pennybags, is remembered by the majority as wearing a monocle. In reality, in every drawing and every game box ever produced, he has never worn one. The classic children's book series, remembered as Bernstein Bears, turns out to have always been Berenstain, with a strange A. The peak of this phenomenon is the death of Nelson Mandela in prison in the 1980s, which thousands of people claim to have watched via live television, while history records that he was released in 1990 and passed away in 2013. Traditional psychological frameworks attempt to cling to the concept of schema, the way the brain fills in information gaps with contextual assumptions. However, this argument collapses when faced with the astonishing uniformity of the error. If this were just random confusion, the errors should be scattered and diverse. But instead, millions of independent brains download the exact same flawed data file, down to the smallest detail, like a hyphen or a single letter. This suggests a chilling possibility. The problem lies not in human retrieval capability, but in the integrity of the source data itself. In distributed system architecture, consider the technique of cache invalidation. When a central server issues a patch to modify variables or update a timeline, a perfect execution would synchronize every storage node instantly. But if the system fails to invalidate old cache versions in certain partitions, those nodes will continue to hold data from the previous version. Observers at these nodes will retain memories of the old version. They are not wrong about what they saw. They are simply holding an unupdated copy of reality. The current record says one thing, but their cache insists on another. The Mandela effect accurately describes this synchronization error state on a cosmic scale. It demonstrates that the timeline is not an immutable ink stroke on paper, but a dynamic database that can be edited. The discrepancies we call mistakes are actually remnants of an old version of reality that were not completely erased after a system update. The universe is running a script where occasionally reality patches are not applied uniformly to all observers. Physics has no framework for collective memory synchronization errors, but a computer system with an imperfect data structure does. We are not just living in a reality. We are living in a version of reality that is frequently maintained and edited, where those with false memories are the ones who have held onto evidence of an old data structure that has been overwritten. Number 1. The Planck scale. Most of us perceive space and time as continuous, smooth, and infinite entities. However, modern physics has reached a fundamental limit where the structure of reality fractures. The Planck length, 1.616 times 10 to the power of minus 35 meters, is not merely the smallest distance humans can measure. It is the minimum resolution unit of the universe. Below this threshold, concepts of position and geometry lose all physical meaning. Einstein's equations of gravity and quantum mechanics clash violently, producing infinite and nonsensical results. Reality at this scale is no longer a smooth flow. It becomes discrete and digitized. Examining this from a software engineering perspective, the Planck scale is effectively the pixel size of the universe. When an electron moves through space, it does not actually glide. At the Planck scale, it disappears at one coordinate and reappears at the next. This is a state update process rather than continuous motion. The universe possesses a fixed data limit. If you attempt to query information at a level smaller than the Planck length, the system ceases to return valid data, similar to overzooming a digital image until only raw, blocky pixels remain. Correspondingly, Planck time, 5.39 times 10 to the minus 44 seconds, represents the frame rate of reality. This is the shortest meaningful duration, the speed at which the universe's processor executes a single computational step. There is no before or after between these Planck ticks. The most staggering realization is that no physical theory explains why these constants have these specific values. They are not consequences of deeper laws, but resemble preset parameters in the system's source code. We have discovered the resolution limit of reality, yet we remain entirely ignorant of who or what configured these numbers. The Planck scale serves as evidence that the universe operates as a finite information processing system, where the hardware of space and time possesses insurmountable design constraints.